Good morning, everyone. This is Group 4, Super Psyched, and today we're about to expound our findings for our research question, which is, do people react more when they see other strangers reacting?
Alright, so what exactly does that mean when we ask if people react more when they see other strangers reacting? What we're trying to test is to see if our actions when we act a certain way in front of strangers will affect directly the way that they react. So if we, for example, turn to look at something, would everyone else turn to look at it?
For this experiment, we're looking at people's reactions towards certain situations, sort of like the bystander effect, only a little opposite. The bystander effect looks at people's actions towards certain situations, or rather, their lack of action towards those situations. The bystander effect looks at people following the social norms that are created within those crowds and not straying from them, where we are looking at people reacting to the situation and not necessarily breaking social norms, but looking out for themselves and reacting to a situation. That leads us to the domino effect, where the bystander effect is not reacting to the situation at hand, where the domino effect is others reacting to people's reactions. And that is actually what we are looking at here in this study, in this experiment. We're looking at people reacting to our reactions and others reacting to those reactions, causing a domino effect.
Prior to our investigation, we hypothesized that more people on our research team reacting to an event will make more subjects react to a hypothetical thing as well. Our first independent variable is the number of members in our team reacting, consisting of 3 levels. Our second independent variable is the gender of the crowd of the people that we are reacting in the middle of. Our dependent variable is the number of people reacting within a crowd.
So why do we think that this will happen? We believe that people will react more when we react more because we believe that the domino effect will be working to our benefit here. So like we said, the domino effect is where if one person shows a reaction, more people will also show that reaction. And if we were ever in a sort of life-threatening situation, it would really benefit us to be paying attention to what other people do. So if other people turn to look at something, then we would also turn to look at it because it could potentially save our lives. So we believe that this evolutionary attitude will be at work here and will make other people look at us when we look at something because they might believe that it would benefit them in some way.
In the journal article titled Culture's Influence on Behavior, Lee Cronk explains that culture is often used to explain behavior, and that we have little understanding of why some culture traits have impacts on behavior while others do not. Similar to while conducting our experiments, some of our reactions had impacts on other people's behaviors while others did not. So why is this relevant to our research question, which is, do people react more when they see strangers reacting? It is relevant because just like some cultures, like in the journal article, adapt traits that will help them survive, similar to our experiment, participants in our experiment became aware of their surroundings when they saw our reactions in order to also protect themselves from dangerous situations.
Okay, so for the control experiments that we used for this experiment are randomization for crowd size. We use different locations and different crowd size amounts to keep the crowd size varied and randomized to make sure that we had a consistent variable. The next one we used is consistency for the reactions our undercovers performed. So for this, we made sure that we consistently used the same reactions, that we did not overreact or underreact during each trial. We use the same moves, we use the same movements, we use the same tones, same facial expressions, and we did not stray too far from those base reactions to keep it consistent, so that way the techniques would not lead too much of a variation for this experiment.
To test our experiment, we walked around campus during transition periods to increase the likelihood of crowd population. After we identified a crowd of 3 or more people, we casually walked in their line of sight and pointed in a specific direction in hopes of facilitating a response. We did this in intervals of 3, 2, and 1.
Alright, so for our experiment, we have 3 different levels for our independent variables. So we would have 1, 2, or 3 people reacting to a hypothetical thing that we're looking at. So for example, for our first level, we had one person point at a thing, like this, and see how many people reacted to us. And then for our level 2, we had 2 people from our research team, and we would point at another hypothetical thing, like this. And then finally, for our third level of our independent variable, we had 3 people from our research team, and again, we would point at a hypothetical thing, like this.
Okay, so during our experiments, it was definitely pretty awkward at first, especially when it was just 1 or 2 of us and not the 3 of us pointing together, because it was really unnatural for us to be pointing, just at a random spot. We would just point at a tree or just a spot in the distance, and it was kind of weird for us to, have people looking at us and stuff. But once we got really comfortable with it, it was really interesting to see as we went up in the levels, level 2 and level 3, how more and more people would react to us. So some people would kind of look around like, oh, what are they looking at? Or they would be kind of scared. Everyone was really paying attention the higher up we went in the level. So it was interesting to see how our experiment was working in real time.
These tables are results for our level 1 reactions for our male participants. As you can see, the percentages of the reactions that were marked for the males that participated in our level 1 were 21.58%. As you can see, it is not very high. Here we have the chart for the female reactions of our level 1. As you can see, the percentages of results that we had for the female reaction is lower than the male results. We have a 13.33% in the female reactions that we marked. Here we have the level 2 results for our male participants. As you can see, the percentage of reactions we recorded was a little higher than our level 1 results for the males. We have a 36.21% of reactions from our males in the level 2, where 2 of our team members reacted to a hypothetical something. Up next we have is the level 2 results for the female participants. Again, the percentage of reactions we received for the females is slightly lower than the male reactions. We have 25% reactions from the females that were recorded in this experiment. Up next we have our level 3 results for the male participants in this experiment. As you can see, we have the highest results of male reactions throughout this experiment in this level. This level was where 3 of our team members reacted to something, and we recorded a 45.45% male reactions in this level. Lastly, we have the results for our level 3 female participants. Here we have the highest results we have recorded throughout this experiment. We recorded a 48.48% reaction rate for females, which is the highest in the experiment once again.
As you can see from the graph that we have up, you can definitely see a positive increase between the levels in both the males and the females, and you can see from the table on the left also that there is always a positive increase as we go up the levels from both the males and the females. There was a bigger jump from the females from level 2 to level 3, but there was definitely an increase for all of them. So that proved that our experiment did show that as we go up in the levels, as more of us react, more people in the general population also react.
So, in order to decide whether our data was statistically significant or not, we ran it through an unpaired t-test, and the two-tailed p-value was equal to 0.5955, and by that criteria, then the difference was considered to not be statistically significant. So, even though we did see a difference and an increase between the levels and between males and females, it isn't considered statistically significant enough to prove or to show that our hypothesis was true.
Some things we would do differently next time is have consistent time periods and days of the week, meaning that we would conduct the experiment on the same day at the same time every week. Next, we would try to have a bigger crowd size to accommodate a higher population sample. Lastly, we would conduct many more experiments, because this time we only had enough time to do the minimum amount required. Some things we would do. This will conclude our final Psych 310 presentation. Thank you for staying tuned all semester. This will